IBM in MuleSoft. Focusing on IBM. IBM in full International Business Machines Corporation, leading American computer manufacturer with a major share of the market both in United States and abroad. Here you can see IBM I integration with Mule ESB. Client summary. In this example, client is based on the Richmond, Virginia, involved in a full service freight transformation, has 160,000 employees, 30 trailers. Their annual turnover is 5 billion US dollars and employees over 100 people. Executive summary. This project is to streamline multi-technology integration process and track the audit of data transfer. Problem statement. The IBM applications are integrated with the third-party applications. Those applications are rapidly integrated without these standards. Solution. The higher level infrastructure for IBM Mule interface consists of three parts. IBM application trigger event, business flow represent the IBM application would trigger the event to transform data through Mule into third-party applications. In transaction interface, the interface with Mule would be at the transaction level with control data indicating the type of transaction. Data queues indexed by the transaction number would act as a trigger to indicate transaction is available for pickup or delivery. Customized staging tables would store the data for each transaction type for Mule to transfer. Mule will act as a carrier to pick up transactions, send the data, receive the response, and relay back the information to the triggering application. Business benefits. No business rules would be present in the Mule layer. The rules will be handled in the triggering and the receiving applications. Sequential transaction number would be the key for all three systems involved. Enables the same business logic to be re-triggered if required. Intermediate staging tables and data queues will be used for Mule to refer to, thus not impacting the master database and speeding up the time taken for transaction to be completed. Here you can see a ERP and web transaction framework can interface programs in AS400. Here the ERP, order entry, POS, inventory, merchandising, etc. Here the ERP interacts with interface program. Interface program interacts with create transaction, CT, CRT, TRN process, and request and response staging. Here create transaction is connected to web control table, ESB types, transaction history, ESB HDR, and transaction errors, ESB log. And here create transaction interact with data queue adapter. Data queue adapter interact with data queue, JMS bridge here, and here the request DQ is connected to AS400 connect or response DQ. AS400 connect is connected to response DQ, and the data queue JMS bridge is connected to flows here, and here the request and response staging interacts with the database connector. Here the database connector is inside flows, and flows inside Mule, and here Mule interacts with third-party applications. Here you can see the detailed steps and areas of responsibility for Mule and IBM I sites in IBM I Business Logic API with Mule. Here the solution design. A high-level design includes the MuleSoft API that invoke IBM I Business Logic programs and execute the request and response data via web transaction framework WebTF. And staging DB for iTables. The flow diagram here explains the detailed steps and areas of responsibility for Mule and IBM I sites. Finally, let's go include with regarding the coding. You will see the building up an API that execute IBM Business Logic is pretty straightforward and includes straightforward. In the Mule create RAML API definition in API design or AnyPoint Studio. Then the Mule generate implementation stuff for RAML in AnyPoint Studio. In IBM I define new web transaction type and interface program. For the IBM I optionally create staging tables for request and response. Mule call WebTF store procedure CTTRN to create new transaction. Optionally insert request data into DB staging tables. Mule optionally call WebTF store procedure PRCTRN to process transaction. Mule optionally retrieve response data from DB staging tables. Mule transform the response data into API response format. Here you can see a Mule and AS400. Here the application event is connected to create transaction. Create transaction is connected to build request. Here the create transaction interacts with CRTTRN via DB2 stored procedure called CRTTRN, and CRTTRN is connected to staging here. And here you can see transaction ID via transaction ID, and staging here TRN HDR, TRN log. And here the create transaction is connected to build request stage STG, and it's connected to the staging here. And build request STG is connected to process transaction. It interacts with the PRC TRN, and it's interact with the business logic gateway, and it's interact with the business logic, and business logic is connected to staging here, and staging is connected to here the return code equal 0 equal OK, and it's here the staging is connected to get response, and here the process transaction is connected to get response, and get response is connected to continue with app flow. Here the application event create transaction build request STG, process transaction, get response, and continue with app flow in Mule. And here the CRTTRN staging PRCTRN in web transaction framework, and here the business logic gateway is in the interface, and business logic is in the application. The web transaction framework, interface, and applications are in AS400. As an example, we can consider this one to publish messages. Here, sending a message to a queue. Here the IBM MQ connector Mule4. The IBM MQ connector version 1.6 Mule4 endpoint connector for IBM MQ. IBM MQ connector enables an app to do messaging to a IBM MQ broker using IBM MQ JMS implementation. The main features include pub sub pattern support for any given destination, listen reply pattern support for any given destination, publish consume pattern support for any given destination with fixed or temporary reply queue, non-blocking publishing and consumption messages. Here, when used in its default form, the connector will publish whichever is in the payload. But what happens if the payload is not in the correct format and you need to make a transformation? You could place a data wave transformation before publish operation, but that would cause the message payload to change and impact the operation placed after publish operation. To avoid this undesired impact, you can now place the transformation inside publish operation. Now the transformation can be used for generating the content that will be published without producing a side effect on the message in transit. This is as an example too, we can consider related to publish messages, publishing a message to a topic. This is a IBM MQ connector Mule4, IBM MQ connector version 1.6 Mule4, endpoint connector to IBM MQ. IBM MQ connector enables an app to do messaging to an IBM MQ broker using IBM MQ JMS implementation. The main features include pub sub pattern support on the given destination, listen reply pattern support for any given destination, pub consume pattern support for any given destination with fixed and temporary reply queue, non-blocking publishing and consumption of messages. The publish operation can also be used to publish message to a given topic destination. All configurations of the operation and message are identical, but the destination type here, destination type parameter has to be declared as a topic destination. For the same example seen before, if instead of sending the message to the queue, we want to publish it to the topic, and here we will do here. As an example 3, we are considering connection modes. Here we are considering client connection configuration on XML. This other mode is binding connection mode. Here the IBM MQ connector version 1.6 Mule 4. The client connection mode lets you to connect to the IBM MQ queue manager running on in the same system that is being run in the Mule application or in other system. In both cases, IBM MQ connector will connect to the IBM MQ queue manager over TCP/IP. For this connection mode are available for the following configurations. Host, this is a required parameter. The host containing the IBM MQ broker. The port default value is 1414. The queue manager listener port. Queue manager. The queue manager used when selecting a channel definition. Channel, name of the channel to connect to, dev.admin.svrcon. Connection name list. Host to which the client attempts to reconnect after its configuration is broken. The connection name list is a comma separated list of host and IP pairs. Here you can see the client connection configuration on XML here. Here we are considering add the connector in Studio. Here we are adding IBM CICS transaction gateway connector, Mule4. IBM CICS transaction gateway connector version 2.3. Anypoint connector for IBM CICS transaction gateway, IBM CTG connector provides integration with backend CICS apps using CICS transaction gateway. For Java platforms, CTG implementations implements the Java cryptography architecture, JCA resource adapter to connect Java applications to the customer information control system, CICS system. The connector serves as a link between Mule apps and the IBM CTG. Here, step 1 in Studio, create a Mule project. Step 2, in the Mule palette view, click search in Exchange. Step 3, in add modules to project, type CTG in search field. Step 4, click this connector's name in available modules. Step 5, click add. Step 6, click finish. Now we are considering before you begin in IBM CICS transaction gateway connector Mule4. To use this information, you must be familiar with IBM CTG, Mule runtime engine, Mule anypoint connectors, anypoint studio, Mule concept, elements in the Mule flow, and global element. You need login credentials to test your connection to your target resource. To use this connector with Apache Maven, view the pom.xml file, dependency information from dependency snippets via link in the endpoint exchange in the documentation. Here you now we are considering CICS customer information control system in terminology in IBM CICS transaction gateway connector Mule4. Set of enterprise application service with the support for high transaction workloads in a secure, scalable, cost-efficient environment. CICS applications are written in a variety of languages from Java to COBOL. Now we are considering adding a connector using Exchange in add the connector to the Studio project in IBM CICS transaction gateway connector. In the Studio, create a Mule project. Click the Exchange icon X in the upper left of the Studio taskbar. In the Exchange, click the login and supply your anypoint platform username and password. In Exchange, search for CTG, select connector and click add to project, and then follow the prompt to install the connector. Now we are considering configure a Studio project in IBM CICS transaction gateway connector Mule4. Drag the connected operation to the Studio canvas. Configure the global element for the connector. Here there are fields required libraries. Here the CTG server.jar, CTG server library, and CICS JEE.jar, CICS JEE, and CCF2.jar, CICS common connector framework, CTG client.jar, CTG client library, and Geronimo J2E connector 1.6 spec.jar. Notes use the jar files that come bundled with the installation of the CTG server instead of downloading the SDK zip from the IBM's website to ensure the compatibility between the connector and the CTG system. Here the host, enter the host name of the CICS TG and port. Enter the port on which the CICS TG is running. Default value is 2006. Server name, enter the CICS user ID, optional if the security is not enabled in the CICS. Enter the name of the target CICS server as defined in the CICS TG configuration file, is optional. Username, enter the CICS user ID, optional if the security is not enabled in the CICS region. Password, enter the password for CICS user ID, optional if the security is not enabled in the CICS region. Hit 3, add the dependencies, select add dependency and complete the fields. Go to the additional settings and complete the configuration. There are here the here the key store location. Enter the location of the key stores containing the certificates required for the SSL client, optional, and key store password, and enter the password required to access the key store for an SSL client, optional. Connection timeout, enter the socket timeout for the client to CTG. Default value is 0, not timeout, no timeout. CTG trace, if set to true, enable all debug level CTG tracing. Default value is false. Response timeout is overridden by the ECI timeout parameter if configured on the server side. Choose the operation. IBM CTG connector supports the following 2 outbound operations. Execute invoke CICS program with the data encapsulated as channels and containers. Execute using Comaria. Invoke the CICS program with the data encapsulated as a Comaria. Requests are limited to maximum 32 KB. You can see POM file information in IBM CICS transaction gateway connector MuleSoft. Replace x.x.x with the version that corresponds to the connector you are using. To obtain the most up-to-date POM.xml file information, access the connector in the endpoint exchange and click dependency snippets. Now we are considering enable logging for request and responses in IBM CICS transaction gateway connector MuleSoft. To enable logging of the interactions of the connector with IBM CTG, a logger must be configured in the log4j2.xml file of the Mule app as follows here. Put the async logger statement in the loggers block in the log4j2.xml file. Now we are considering common use cases in IBM CICS transaction gateway connector MuleSoft. Invoke a Comaria program, invoke a channel program, invoke a Comaria or channel program inside the transaction scope, add the custom metadata. Note, to successfully run the first 3 use cases, the target CICS system must have the specific programs. Now we are considering IBM create a configuration file for a connection in configure a connection in IBM CTG connector 2.3 examples in MuleSoft. Create a configuration file that includes the properties for a connection. Create a file name mule-app.properties in the /source/main/resources/folder. Source as resources folder. In the mule-app .app.properties file, create a set of properties for the connection similar to the ones that follow, replacing the bracketed text, including the brackets with the correct values for your configuration. This may vary depending on the selected connection configuration. For more information of creating a properties file, refer the configuring property placeholders in the documentation. Here you can see the IBM.host, host name, IBM.port equal port number, etc. Now we are considering parameters in configurations in IBM CTG connector reference Mule4. Here the name, parameter name, the name for the configuration, for this configuration, connectors reference the configuration with this name. Now we are considering client connection mode in IBM MQ connector. The client connection mode lets you to connect to IBM MQ queue manager running in the same system as that is being run the Mule application or in other system. In both cases, IBM MQ connector will connect to the IBM MQ queue manager over TCP/IP. For this connection, the connection mode are available following configurations: the host required, host contained in the IBM MQ broker, parameter port and not required, and default value is 1414. The queue manager listener port, parameter queue manager not required. The queue manager used when selecting a channel definition, parameter channel not required, name of the channel to connect to, parameter connection name list, not required, and host to which the client attempts to reconnect after the connection is broken. The connection name list is the separated list of host and IP ports. For example, 0.0.0.0.0 within bracket 1414, some host .domain.com within bracket 1415. The client connection configuration on studio here. Here the client connection configuration on XML. Now we are considering define global defaults. In IBM MQ connector Mule4, the IBM MQ config allows you to define multiple parameters to use as a default while consuming or publishing messages. This way you can define a global default behavior for all the operations associated with the config and override each parameter only when the operations that require custom behavior. For example, we can define the default selector behavior when consuming a message in any of the operations that are associated with this config, and also a default. In this case, every consume or a listener operation associated with this configuration uses the selector by default, while every time a publish or publish consume occurs, the outgoing message has a TTL of 60 seconds. All of these properties can be overridden at the operational level when required. To publish the message with the shorter TTL, use this example configuration that overrides the parameter. Now we are considering select a JMS spec in IBM MQ connector Mule4. So the main command parameter is a JMS specification used to select between all supported specification, which are 2.0 and 1.1. This specification must be supported by the broker implementation associated to this connection, otherwise the connection fails. Warning: features available only in JMS 2.0 won't work with any other specification. Now we are considering provide credentials for authentication. To establish the authenticated connection, you need to configure the username and password in the element. Now we are considering set up the connection required libraries. IBM MQ external libraries. To use the IBM MQ connector, configure the external IBM MQ library. The IBM MQ client library must provide com.ibm.mq.jms.mq connection factory implementation. Tip here, use the IBM MQ all client library. For example, you can use this one. Now we are considering parameters in configurations in IBM MQ connector reference Mule4. Here the parameter name, the name for this configuration, connectors reference the configuration with this name. Now we are considering add a namespace for the connector in IBM MQ Connect XML and Maven support Mule4. This example shows how the namespace statements are placed in the Mule XML block here. Here you can see a manual acknowledgement in handling message acknowledgement in IBM MQ Connect example in Mule4. As you may expect, the manual ACMOD here, the manual ACMOD delegates all the responsibility of the performing act ACK on the message to the application logic. With this configuration, every message received by either in the listener or consume operations as a ACK ID available in the Mule message attributes, which identify the message uniquely for a given connection. Here with this configuration, every message received by either listener or consume operation has an ACK ID available in the Mule message attributes, which identify this message uniquely for a given connection. ACK ID that identify the message passes the IBM MQ :ACK operation. do message processing. Now we are considering increasing concurrent message processing in IBM MQ tuning for performance. A good way to improve the performance of your application is to increase the number of concurrent consumers that receive messages from the same destination. This can be done easily in IBM MQ connector by configuring a number of consumers parameters. Out of the box, the listener uses 4 consumers concurrently at the same destination, but you can increase this number to a value that better fits your needs. Increasing the number of consumers is the easiest way to improve the throughput of your listeners' destination. Now we are considering enable verbose logging in troubleshooting IBM MQ connector Mule4. Sometimes you are not sure why your application is failing, and you require a better understanding of what's going on in the app's interaction with the MQ server. To gather detail logs, use the configuration file to increase the logging level on the server side, and also enable verbose logging for JMS connector and MQ packages. Access the Anypoint Studio and navigate to the Package Explorer view. Open new applications project name. Open the source main resources path folder. Open the log4j2 XML file inside your folder. And in the following line is already in the log4j2 XML file. Uncomment it to enable it, otherwise add it. As an exception example, we can consider this one: fail to deploy. This is occurred in IBM CTG connector. Fail to deploy artifact IBM CTG connector. See below, and org.mule.runtime module.license.api.exception.invalid license exception. Runtime license does not contain entitlement IBM CTG connector required by plugin IBM CTG.